Greetings, globeheads and flurfers. Have you ever heard the expression, through rose colored glasses? He sees the world through rose colored glasses. I don't know how popular this is in other English speaking countries, but I'm sure everybody in the United States has heard this expression at one time or another. What does it mean? Well, it means that this particular person that you're talking about doesn't see the world as it really is, but perceives it colored by his perception. In this case, rose colored glasses would indicate like a positive view of the world. But how does this expression come about? Well, if you had glasses on that had a color tint to them and the filtered the light coming in into a particular color, that's what you would see. When I was a little kid, I had glasses that were very, very, very blue, sunglasses. And when I put these on, everything was blue. I really, really enjoyed wearing them because the sky was literally blue every day with these glasses on. I probably never would have stopped wearing them until I grew out of them, except for that at some point or another I sat on them and broke them. But this is what I want to talk about today. Um, there seems to be some misunderstanding among the flat earth community about what it means to see something. And I think this is a good example of it. Um, it's almost like flat earthers think that when you see something, your eyes reach out to that thing and see it. That's not what's happening. If you look out onto the horizon and you see a boat, for example, you are not seeing the boat. You are seeing any light that hits your eye. And if some of the light hitting your eye has reflected off of that boat in such a way that you can distinguish it from other objects, then you will see it. This is a really, really important distinction because if you understood this, it might clear up some of the misperceptions that you have about things that you view in your reality. You see, when you pass light through a medium, such as a color filter, it's going to change what light hits your eye and what you perceive from that. Just like if you put a blue filter or a green filter between an object and your eye, and you will see that object as blue or as green, even when it's not. Light can pass through other mediums as well that will change or alter the way you perceive that light. I've heard a bunch of flat earthers, and I believe the last one I heard trying to make an argument related to this was D. Marble. I've heard a bunch of flat earthers making an argument that, well, if the light on Earth comes from the sun and the sun is in space, then how come it's dark in space? Well, the light that you would see in space, the only light you would see in space, or anywhere else for that matter, is the light that's hitting your eye. Okay? So if you're floating in space and you look up and the sky is black except for one real bright spot where the sun is, that's because all the light leaving your sun, all the light leaving the sun and going off in different directions, none of it you're going to see except for that light that hits your eye. And the only light coming from the sun that's going to hit your eye is the light that travels directly from the sun to your eye, not the light going out in any other direction, unless that light that goes off in some other direction then reflects off of some other object then you're going to see the light that bounced off that object and eventually hit your eye. How hard is that for you to understand? The argument D. Marble was making is the sky is black in space, and it's blue on Earth, and that doesn't make any sense. Well, it doesn't make any sense if you're as ignorant as D. Marble. But you see, there's one big, huge difference: the medium that light has to pass through. Flat earthers like to pretend that air is like some substance that we breathe that has neither mass, weight. It should float off the globe, and they don't understand the gravitational effects on air. They don't understand, how we have air pressure without a container, all that. But they also don't understand that air is not perfectly clear. The light does interact with air molecules, and when it does, we have very interesting effects on Earth. It diffuses or scatters that light as it hits air molecules, and it causes an ambient light. What is ambient light? Well, the difference between light and ambient light is the same difference as being in space and seeing light only coming from the sun versus being in a room or on the earth where the air seems to be filled with light. Everything around you is light. Another example, you're at night, you're in a big warehouse, and somebody at the other end of the warehouse has a flashlight. Well, it'll look dark in the warehouse to you, except for that flashlight at the other end of the warehouse. You'll see that beam of light. If you have enough light in that warehouse that you have ambient light, then the whole lighthouse, the whole warehouse is lit up and you can see everything. The beam from the flashlight will not be as noticeable. We get ambient light from light bouncing off of all kinds of things around us, but in the air, we get light that is diffused and diffracted and goes all over the place, and so you see this light. Now, the different wavelengths of different colors of light are different. This is exactly how we perceive the colors. Is our eye picks up these different wavelengths and translates them in our brain to colors. But the different wavelengths are affected by the air molecules differently. And that's why you see the sky as blue. The way that the blue light interacts with the air molecules is different than the way the other wavelengths of light interact. So we see a blue sky. Perhaps if we were on another planet and we had atmosphere made from a completely different gas, the sky would be a different color. I don't know. You would have to ask somebody far smarter than me. Ask Fight the Flat Earth. He's a real bright guy. But you do need to understand these things before you just start spouting nonsense to try to prove your theory that just instead shows your ignorance. The last video I saw about this was a video made by I don't even remember the guy's name. Can't remember. Sorry, I can't remember his name. But this guy made a video where he's showing the light reflecting off of other objects and comparing it to the light reflecting off the moon, and supposedly using this as evidence that the moon is not a sphere like we say it is because the light doesn't reflect off of it right. Well, here's the problem with that. Light reflects differently off of different surfaces. The light reflecting from a basketball, a tennis ball or a cue ball. It's all different. Look closely at those and you'll see what I mean. The smoother the surface, the more likely it is that you will see when light shines on something that it reflects brightest where it hits straight on and reflects less as it gets, you know, less straight on from the light source. But when you have something with a rougher surface, like a basketball or a tennis ball, or say the moon, you're more likely to get light reflected in all different directions. And when this happens, you're going to get a little bit different look of the reflection than you would off of a cue ball type of situation. See, if you flat earth folks would take the time to learn how light works and how your eye works, then you wouldn't come up with such stupid nonsense like denying refraction. Your most powerful argument in your mind is how you can see things around the curve of the earth that you shouldn't be able to see. And yet we know so much about refraction that we can often calculate how much it will happen in different situations. And if you don't believe refraction exists at all, go out on a nice sunny day with a perfectly straight cue stick and dip the end of it in the swimming pool. Why does it look like it bends under the water? This is called refraction. As the light goes through this medium, the light is refracted. Its course is changed. This is science that we all understand. And when you just say, oh, refraction's just an excuse, all you're doing is demonstrating your own ignorance. Learn about it. Learn what it is. Study it. And then see how it compares to your argument instead of just being simply dismissive. What you see as the boat goes over the horizon is you see light hitting your eye. Nothing more, nothing less. And as long as light can bounce off that boat, reflection, and still get to your eye, whether in a straight path or by refraction, you're going to see the boat. Once something is blocking the path, you will no longer be able to see it.
But Danny, sometimes stuff just goes too far away for you to see.
Yes, that is true. But you know what? The sun doesn't.
Well, yes, it does.
You're going to have to demonstrate to me absolute proof that it gets smaller and smaller as it gets further away from you. Because the only way something can get small enough to disappear without going behind another object is if it continues to get smaller as it gets further away. You don't just go same size, same size, same size, same size, gone. Look around. Look at cars on a freeway going off in the distance. Look at everything you see around you. You will never see an example where something is same size, same size, same size, same size, gone. Just doesn't work that way, sorry. Learn about how light works before you spout nonsense that makes you look stupid.